All right, so let's work through this lab here, the hitting the target lab. So based off of the sample data, there basically were two parts to this lab. So I'll just explain what was done in class, then we'll talk about how to actually do it. So for the first part, we had an object fired horizontally from some initial height. Okay, and it flew through the air and landed on the ground. And people were able to measure this distance here, the horizontal displacement, along with this height here. So that was the data that you were collecting. And ultimately what you were trying to do for that first part was figure out what is that initial velocity that is launched with. Okay, so a number of trials were done, repeating this procedure, each time getting the height, which obviously didn't change, and the displacement, which was basically the same, but it might have varied a little bit. For the second part of the lab, all right, we took that initial velocity that we initially got, and then we took our projectile launcher and launched it up at an angle. So it was launched from the same height as before, but obviously now it was launched up at an angle, flew through the air, something like that, and landed at some different position. So the goal for the second part was to consider where it would land. Okay. Now the thing you knew that was the same was whatever initial velocity you got for this first part, that became this initial velocity. For the second part, it was just at an angle. So what we had to do was, based off of the angle it was launched at, which was known, you had to figure out the x and y components and then set up your projectile motion in both the x and y direction to ultimately get how far it goes. So let's take a look at the sample data and a few things with the setup here. So for that initial launch, that was that horizontal launch, we're going to set up our chart in both the x direction and the y direction. Okay, so there's our x chart, delta x, VIX, AX, and T. And then we're going to do the same thing in the y direction, delta y, VIY, VFY, AY, and T. And we're going to fill in all the things we know. Okay, we of course know our two accelerations in both the x and y directions because we always know that for projectile motion. The height is going to be our delta y here. The average of the horizontal distance is going to be our delta x because again we have that horizontal launch like that. So here that height is our delta y. How far it travels horizontally is our delta x. We also know something really, really important about things that are launched horizontally that tells us one of these variables here, and our ultimate goal is going to be to find this VIX, our initial velocity in the x direction, because that was the initial velocity it was launched with when it was launched horizontally. Once we have that, we're going to take this same basic setup here, okay, and we're going to now think about our angled launch, all right? So we're going to say we have, once again, delta x, VIX, VFX, AX, and T, all right? We also have our y set up here, which is going to be delta y, VIY, VFY, AY, and T. Once again, we're going to know our accelerations in both the x and the y direction. Okay, so that's one piece of information that we know. Our height, we still know. And then the other thing we're going to be able to do is we're going to take whatever we got for this initial velocity up here, we're going to put that at an angle, all right? So that initial velocity that we calculated in the first part, we're going to put it at an angle, and we're going to be able to find the x and y components of it based off of this 60 degrees. So we can get this, which will be our VIX. You have to think about whether that's sine or cosine. And this, which will be our VIY. So you'll also have to think about whether or not that one is sine or cosine. And we can put that in over there. It is a little bit tricky mathematically, the second part, but start setting it up and work through it the best you can.